guys, Miss Davis here. I just wanted to show you the two formulas that you need for the section on growth and decay. Just a quick reminder that anytime you multiply a number by anything greater than 1, the number's going to get bigger. And on the contrary, if you multiply any number by something less than 1, the number's going to get smaller. So obviously your growth is going to be when you're multiplying by a number bigger than 1. A number or a situation will decay or decline or get smaller if you're going to multiply by anything smaller than 1. Now let's talk about the two formulas that you're going to need. Okay, you will notice the formula is up there in turquoise. This is your growth and decay formula. It says y equals a times b to the x. I know, I don't know why they have to use these crazy numbers, or letters, sorry. But I do want you to recognize the similarity between that and the compound interest formula below it. So I wanted you to see the similarities, but just know that this is not the formula you're using, but I wanted you to notice that it is similar. This is the amount. A does indeed represent the principal or your starting amount of whatever situation you're talking about. X is your exponent, which is the same as your time. So those, again, are the similarity. And then B is indeed your growth factor. And so over here in yellow, you can see that if the situation is going to get bigger or grow, then we have to add the rate to 1. Now remember, your rate is going to be a percent that you're going to convert into a really small decimal. But when you add that to 1, again, because you're going to be multiplying by a factor greater than 1, then your situation is indeed going to get bigger. Notice the decay is when you subtract the rate from 1. So you're going to subtract this little decimal from 1, which is going to just give you a number smaller than 1, causing your problem or situation to decline or decay. So let's go ahead and do an example, and I'm thinking that it might make a little more sense. So we're going to look at the house situation first. Typically in our country, houses appreciate. They go up in value, they grow, okay? So we're going to take our situation, we're going to take our formula, so y equals a times b to the x, and we're going to plug in our values. The first thing that you really should do is figure out your growth factor. So if my R is 3.5%, you must convert that to a decimal. Okay, so that's 0.035. But then remember, we have to add that to 1 because we know that it's a growth situation. So it's almost like we're putting it back up into this formula up here, and we're going to add it to 1. So our B in this situation is actually 1.035. Okay? Now, our X is really just a fancy word for our time. So in this case, our time is 10 years. So our X equals 10. And our A is our starting amount, which that is 300,000. So 300,000 would be our A. Just make sure that you're doing things in the correct order of operation. So you need to know that exponents would come before multiplication. So it's important that we take our growth factor and raise it to the power of 10 first. Then we can multiply by our 300,000. And then you would just do this on the calculator. Okay, so I am getting 1.035 raised to the power of 10 is 1.41059 blah, blah, blah. I'm not going to write it down, but I'm certainly not going to round. I'm just going to leave that answer as is, but then go ahead and hit my last step, which is to multiply by my 300,000. I hit equals, and I'm showing that this house would now be worth 10 years later $423,000. And then, of course, you always ask yourself, does that make sense? If it's going to grow, is the number bigger than what it started? And so, yeah, that does sound about right. So that is how you apply the growth formula. First, find your growth rate. Then take that to the exponential power, which is your time. And then the step 3 would be to multiply by your initial amount. And you're done. Now let's try a decay. Okay, now we're going to try a declining situation or a decay situation. A situation where our number is going to be smaller at the end. So in this case, we are doing a car. I have a truck here that's going to depreciate. So again, you're just looking for those keyword, those red flags, so that you know, am I using a growth situation or a decay situation? So typically, houses appreciate and vehicles depreciate. So let's say you buy this truck and it is $40,000. Trucks are expensive nowadays. And let's say that you know, or the dealer told you that it's going to decline approximately 2.5% every year. Probably way more than that, but just pretend. And you want to know, what is your truck going to be worth after 7 years? Okay. So here we go. Again, we're using the same formula. It's just now we have a decay situation. So we're going to end up subtracting our rate from 1. I'm going to grab a different color because that's kind of hard to see. So here we go. Our decay situation. So step 1 is to calculate your B. So B equals 1 minus our R. Our R in this situation is 0.025. You're taking your percentage rate and you're converting it to a decimal. So 1 minus 0.025 gives me a decay rate, or a B, of 0.975. Okay, so that's my B. So I'm going to go ahead and plug this into our situation. So here we go. Y equals A, my starting amount is 40,000, times B, so this is my B. I usually put it in parentheses, but you don't have to. 0.975, and we're going to raise it to the exponential power, which is our time. In this case, our time is 7 years. So I'm going to go ahead on my calculator. I still have my 0.975 there. I'm going to raise it to the exponential power of 7. And I get some long crazy decimal, 0.8375, blah, 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 blah. I'm just going to leave it. I'm not going to round, and I'm just going to hit multiply by 40,000 because that is the last step. And I'm showing that after 7 years, this truck would be worth 33,000. Now, I find that very hard to believe, but we're just going to pretend. 503. So again, as long as you're multiplying by a growth factor less than 1, your number at the end should be smaller than what you started with. And this is indeed a decay situation. Next, we're going to talk about continuous growth or continuous decay or decline. So now notice these two formulas are different. They're very different. So you will need to write these down, and you will need to know that the key word that you're looking for in these word problems is indeed that word continuous. If you have the word continuous, you cannot use the other formula that we just did. So this word problem does indeed say continuous, continuously, whatever, so you know you're going to be using one of these. Notice the growth one has a positive exponent, a positive R, whereas the decline, notice the R will be negative. So we're going to do one of each. So here we go. Let's just plug these in. Now, I do want to point out, E is not a variable. E is literally a value and a button on your calculator. So here we go. A equals P. Our P is your, again, just your principal, your starting amount. So here we're starting out with a population of 56,000 at a movie theater. and then times E. I'm leaving E as is because I need to use that on my calculator. And then my exponent is the rate times the time. Well, my rate is 0.042, and my time is 9 years. So I'm going to go ahead and multiply that off to the side so I can just have the correct exponent in my formula to begin with. So 0.042 times 9, I'm getting 0.378. I know it's looking wonky, it's looking weird, but it's going to work, I promise. Okay, so here we go. Then I'm going to clear my calculator, and I am going to take the E button, and I'm going to push that E button, and it should say like 2.7, blah, 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 blah. It's almost like you can think of it as maybe like a pi symbol. Like pi actually equals 3.14, E actually equals a value. So I push the E button, and I hit the raise it to the power of, or the exponent button, and then I'm going to put in 0.378 equals, and I get, again, some crazy decimal, 1.45, blah, 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 and I'm just going to leave it. And then my last step is to go ahead and multiply times my original principal amount. So when I multiply by 56,000, I'm showing the population at the movie theater, if it continuously grows, will be 81,724 people after 9 years. That is different than the growth factor that we were doing before, okay? You have to use this formula if the problem says continuously. Okay, now let's quickly try a decline. So that's a little bit different. We're going to have a negative rate, which I know sounds weird, but again, it will work out at the end. So here we go. Amount equals principal. So our starting amount in this situation, this business has 46,900 customers. Whoa, sorry. And we're going to multiply that times E to the power of. Okay, so now, again, let's figure out our exponent kind of off to the side. So it's our negative rate times our time. Whoa, okay, so negative rate is negative 0.032 times 8. So I would punch that in your calculator off to the side. And I am showing an exponent of negative 0.256. Okay, so I know this looks weird, but we'll be okay. Now I'm going to clear my calculator. I'm going to push my little fancy E button. I'm going to raise it to the power of negative 0.256 equals, and I get 0.77 blah, blah, blah. I just get some long decimal that's less than 1, which is good because I know that when I multiply the last step by multiplying by 46,900, I'm going to indeed get a smaller number, which is what I needed to because this is a declining situation. And I'm getting a final answer of 36,307. Okay, so hopefully this clears things up of when you use which type of growth and decay formula. The basic one is what we did before. This is only if the problem says continuously. And hey, these two problems might look familiar on your next quick check or quiz. So I'm glad you watched this video.